All right, let's look at two more improper integrals here of the type 2, the discontinuous. Here we're going to take the integral from 0 to 3 of 1 over x minus 1 dx. And a quick look at this one should make us recognize that our discontinuity is going to happen at x equals 1. There's a vertical asymptote. So, well, let me do it like this. There we go. So at 1, we have a vertical asymptote. Okay. And this graph, of course, would look like 1 over x, just shifted to the right one. So it's going to look like this and that. And we're interested in the integral from 0 to 3. And remember, this vertical asymptote happens at 1. So what's going to happen with this? Well, this is where the discontinuity is between a and b, which is this example right here, where we're going to split it into the two. Now, we could split it into the integral from 0 to 1 plus the integral from 1 to 3, but of course we don't want to use 1, so we're going to replace those with t's. So we're going to take the limit as t goes to 1 from the left of the integral from 0 to t of 1 over x minus 1 dx, plus the limit as t goes to 1 from the right of the integral from t to 3 of 1 over x minus 1 dx. All right, so antiderivative time. And the antiderivative of 1 over x minus 1 here, just a simple U substitution would give us the natural log of the absolute value of x minus 1. That's from 0 to t, plus the limit as t goes to 1 from the right. This would be the same thing, natural log of the absolute value of x minus 1 from t to 3. Let's substitute in our t. So the natural log of the absolute value of t minus 1. Now here, what's going to happen when we substitute in that 0? We are going to be taking the natural log of the absolute value of 0 minus 1. The absolute value of 0 minus 1 is positive 1. The natural log of positive 1 is 0. That's gone. Plus the limit as t goes to 1 from the right. Now this is going to end up being the natural log of the absolute value of 3 minus 1, which is the natural log of 2, minus the natural log of the absolute value of t minus 1. So now it's time to evaluate our limits. And let's think about what the graph of the natural log of the absolute value of t minus 1 would look like. Well, we know what the natural log of t looks like. That has a vertical asymptote at 0. Oh, where's my graph? Here it is. Okay. So, I needed those parentheses and the absolute value. Right, so this is the graph of the natural log of the absolute value of t. Typically, we wouldn't see that left side because you can only take the logarithm of positive numbers. However, because we have the absolute value, we get that graph on the left, but that's not important, right? Because we're only interested as we approach 1 to the left. However, we need to put that minus 1 in here, which is going to do what to the graph? It's going to move it right 1. So where is x equals 1? It's where that vertical asymptote is. So when we ask ourselves, what's the limit of this function as t goes to 1 from the right, it goes down to negative infinity, okay, which tells us that that limit does not exist. Okay. Now, we don't even have to go on, right? Because if this doesn't exist, then the sum of something that does not exist with something, even if it does exist, wouldn't work out for this. So this is a does not exist. So this is another one that is divergent. There we go. All right, let's look at one more. Integral from 0 to 1 of just the natural log of x dx. Okay, so we're actually pretty close to that here. There we go. So here we have the vertical asymptote on the left because we're interested in the integral from 0 to 1, which would be this region below the x-axis. Because it's on the left, we will set this up as the limit as t approaches 0 from the right side of the integral from t to 1 of the natural log of x dx. Okay, so antiderivative of the natural log of x is x natural log of x minus x. That should be straight from your derivative antiderivative rule book. We're going from t to 1. All right, substitute in our 1. We have 1 natural log of 1. Natural log of 1 is 0. So that just ends up being a 0 minus 1, which is negative 1, minus, now substitute in your t, like that. Negative 1, let's distribute the negative. All right, now it's limit time. What is the limit as t goes to 0 from the right of negative 1? That's just negative 1. Minus. Now how about t natural log of t? So, hold on, I have a visitor, just a moment. All right, so where was I here? We are trying to figure out, that's right, t natural log of t. Okay, we want to find that limit. So, t natural log of t. And let's see here, we're taking the limit as we go to 0 from the right. Whoops, don't look at that. As we go to 0 from the right, it goes to 0. Look at that, check this out. Right, approaches 0. That's very nice. Plus, what is the limit as t goes to 0 from the right of t? Well, that would just be 0, right? I mean, that's just our classic y equals x. In this case, f of t equals t line. As we go to 0 from the right, that approaches 0. This thing does converge, and it converges to negative 1. There we go. So those are our type 2 improper integrals. So that's really good. We're going to learn some strategies here in the future on how we can use some of the things that we've done with our type 1s and our type 2s to handle a little bit more difficult improper integrals. But I think that's good for now. Peace out.